of resistance causing the same harmonics. That was the big flame you saw at the beginning, leaking off the disconnect switch. Now, the normally constant or time invariant coefficients change in value with respect to time. Now we have a peculiar set of dimensions of henries per seconds, ohms per seconds, farads per seconds, and Siemens per seconds, and this is where the concept of the law of conservation of energy comes apart. Because the energy is appearing and disappearing in these relationships without any equality or connection anymore. Energy can either vanish or energy can appear in the system. Steiner states in Article 241 of his theory and calculation of alternating current phenomena, published in New York in 1900, the following. We find here a case of a circuit in which the power factor, that is, the ratio of watts to volts amperes, differs from unity without any phase displacement in the phase of the cycle. That is, while the current and the EMF are in phase with each other, but are distorted, the alternating wave cannot be replaced with an equivalent sine wave, since the assumption of equivalent sine wave would introduce a phase displacement of an angle that doesn't exist. This condition made itself apparent in the line switching equipment of the primordial electrical industry. Let's see if we have something. So this is a prime example of what happens. Okay? We're trying to turn off a 220,000 volt power line. This is the switch. It stands about 50 feet high. Now what they've done is, in order to eliminate the oil tanks, which normally break the day discharge, they're using vacuum columns. And what it is the mechanism breaks the circuit inside the vacuum columns. But being that there's no gas or oil or anything to carry the current through to the zero part of the cycle, the voltage tends to, the voltage tends to raise to infinity, trying to maintain the power flow. This is where the switches start to explode as they're opening here. Now normally these cells here break the electrical circuit in the vacuum so there can be no arc, but that's kind of the last thing you want to do because the momentum of the electricity will come thundering back down the line to try to keep it going. And what I just read from Steinmetz is in the actual arcs where the switch contacts are breaking open, is you start to get energy anomalies in these arcs. And the system goes into a cumulative oscillation and continues to accumulate energy until something blasts. So as we go through the opening of the switch, you can see where now the fire has jumped across and there's no way to stop the flow and it's just accumulating. I think we've got one more shot before it explodes. There we go. Now it's getting ready for the final blast. And then the final shot, that's another switch. Okay. That's the final shot where it shorts out the power line. The intensity of the light's so great that the camera can't really, it's shorted out the camera. So you can't really see the, you can't see it at this point very clearly. It buzzed it out, but that's a lot of power there. You're talking about the electrical discharge there is probably equivalent to maybe 20 locomotives running full bore, hauling trains over the Tehachapi Pass.
But I'm sorry, I just want to get this right. This is interesting. A plasma is established inside these vacuum switch chambers?
No, the whole idea is to have no plasma.
Right.
But that being that the current is not cut off at a zero point in the cycle, as the electrical momentum starts to come thundering back down the line to maintain the current.
So plasma is created in this process?
No, the inside does not create a plasma, but the problem is the voltage gradient goes so high. Let's go. We go back to the first one. When it first starts to blow, okay. What happens is it's the voltage gradient now, the electric field around this. We'll get into it later. This is not just objects in isolated space.
That's right.
The electric field density has become so severe, okay, that it has to strike out in the atmosphere to create a plasma because it can't create it in the switch. So you might have an electrical field here in the order of maybe 10 or 15 volts per megavolts per centimeter. And so the fire breaks out. See, normally when the switch opens, the remaining fire is dissipated in these opening arms. As you see going through the video, it goes step by step. These were live pictures, but we didn't have they're stunning to watch move. So you can see now the arcs have come off the switch and now found their way back to the line terminals. And there's no way to stop this now. And then the arcs are changing resistance. This is the key thing. The arcs are cyclically changing their resistance with respect to time on the alternating current cycle And in the process of doing this, they're creating an imaginary, or I would say imaginary, but another dimensional energy that has to come out into this dimension. And this is a process very worthy of study. This is what Steinmetz is mentioning here in Article 241.
Then I would like to wonder about one thought. Because a lot of folks keep getting, like Art Bell, for instance, keep getting these mysterious voltages occurring on their antenna arrays, is that related to this concept here?
No, not directly.
But it does indicate that there's something else coming in from a different dimension set, maybe.
Well, what it is basically mutual induction to the ionosphere and the sun. And those electric fields are always changing, but it is an electrical gradient. But there's no plasma other than the sun itself. But then we're getting into a system with much larger dynamics and more factors come in.
So that might concept.
Right. Okay, so let's see. Okay, the condition made itself apparent in the line switching equipment of the primordial electric industry. Large transmission lines and substation transformers refused to be de-energized without some large fire or blast. This is a substation going up when they couldn't turn it off. So three shots here. So this is what they were dealing with, and it wasn't a happy situation, and they had no way to stop it. If you tried to turn the stuff off, this is what would happen. And people got unfriendly about it, not alone the people that paid for it. In addition, it was not as if they were creating their own energy. Let's see, I left off something here. AC power distribution could not progress because of this condition. It was as if they were creating their own energy, and this energy would not appear on the switchboard instruments of the power system. Energy now had a new meaning, and engineers felt a new era in the process of making. This is when Steinmetz wrote his next famous book, was on this topic. Situation came to a head to a crisis level for both GE and Westinghouse, who were pointing fingers at each other that their line switching equipment was, the other guys was bad and theirs was good. And they couldn't share the deal, so when the whole thing blew up, they had to start pointing the fingers. So what happened is the electrical system for the Manhattan Elevated Railway is what we're talking about. So the Manhattan Elevated Railway blast and ensuing shutdown in 1903. At the time, it was the world's largest steam-driven electrical generating plant. The capacity was 40 megawatts with a voltage of 11,000 volts from phase to phase. Singing static discharges and surge arresters began at one railway substation, and then another railway substation. Shortly afterwards, a massive underground blast raised the street around the splicing manhole. Many of the 5 megawatt alternators suffered damage. Upon analysis by Steinmetz, it was that a progressive or cumulative oscillation had developed, evading station voltmeters. This oscillation cohered at 270 cycles a second in the entire electrical system with a wave crest of 120,000 volts. That's a lot of buildup over 11,000 volts. And the final fault current was a fault current of 9,000 amperes. So we're talking about a pretty good bang. That's why the whole street lifted up 2 or 3 feet. Out of this work, Steinmetz developed the synchronous condenser, a type of dynamotor that one may be tempted to call a free energy device. This machine is utilized by the utility companies to provide part of the power to their transmission system that would otherwise have to be produced at the distant generating facility and thereby cause a waste of power in its transmission. So basically, the electrical power industry is in a certain sense already using so-called free energy concepts because it's inherent in the distribution system itself when it gets to a certain size. And you're using the synchronous condenser, which is a very large synchronous motor that's immersed in hydrogen gas. The reason it's immersed in hydrogen gas is to cut the windage down, and hydrogen is a heavy absorber of heat. So they can keep the machines cool and they can keep the windage losses down. The motor only connects to itself electrically. And through this synchronous parameter variation, what this motor does is become a generator by working its own phases inside and supplies all the magnetizing power for the system necessary to keep the transformers and transmission lines magnetized. And between the synchronous condenser and the substation at the distance end, in my experiments, I've determined that energy is actually synthesized in the space between the wires in the magnetic field. Now, I did an experiment with this when I was at the Richmond shipyard. I took there was 10 synchronous motors in an air compressor plant. Each one stood about 15 feet high. They were 500 horsepower machines. The air compressors were all unloaded so that the motor could spin freely. And then we attempted to turn one of the kilowatt-hour meters backwards. They call it the kilovolt ampere reactive meter. That measures how much your induction motors and what have you are pulling magnetic power out of the system, keeping the wires up. So we created roughly about a 5 megawatt reverse wave. Okay, and the meter was pinned so it wouldn't go backwards, which is what you would expect. So we kept raising the power level. Well, this power worked its way down Canal Boulevard, and then the plant engineers at the various Shell and Oil Standard and all the rest of the pumping facilities there probably heard their motors starting to sound much more musical as they started absorbing up all this magnetizing force. When it found its way back to the bus bars in the substation, the reverse power relays opened up the 110 kV circuit breakers on the primary side and shut the city of Richmond down. So I think that was a successful experiment. Steinmetz only professed to go so far in the area and was prohibited by his employer, General Electric, to divulge company secrets. The implications are power systems that can become partially self-sustaining. When asked by GE if Steinmetz thought that he might have some new type of electricity, his reply was no, but I think he was lying. So Tesla gets into the concept of electricity here, and we're going to start taking it apart pretty soon and get into the details of it. So hopefully everybody will leave here with some kind of picture in their mind of what electricity is and how it works. So Tesla states in a lecture before the American Institute of Electrical Engineers in 1891 the following: I adhere to the idea that there is a thing which we have been in the habit of calling electricity. The question is what is that thing? Or what, of all things, the existence of which we know we have best reason to call electricity? We know that it acts like an incompressible fluid, that there must be a constant quantity of it in nature, that it can neither be produced nor destroyed. And what's more important, the electromagnetic theory of light and all the facts observed teach us that electric and ether phenomena are identical. The ether at once suggests itself, therefore, that electricity might be called ether. Remember that we must remember that we have no evidence of electricity, nor can we hope to get it, unless there's gross matter present. Electricity, therefore, cannot be called ether in the broad sense of the term, but nothing would seem to stand in the way of calling electricity ether associated with matter or bound ether. This was Tesla's idea of electricity in 1981.
1881?
1881. This is 1891. Sorry. So Whittaker states that age which preceded the birth of Descartes in 1596, and that in which he lived, was marked by events which greatly altered the prevalent conception of the world. The discovery of America, the circumnavigation of the globe, the invention of the telescope, and the overthrow of the old system of astronomy. And general dissatisfaction with scholasticism, and to make plain the need for a new structure. This is what Descartes set himself to erect. Now, one of the problems of natural philosophy was to account for the actions transmitted between bodies not in contact with each other, such as with magnets. To accept these as occult influences would have been contrary to his principles. This implied that bodies can act on each other only when they are contiguous. In other words, he derived action at a distance, and this had the further consequence that the space between the moon and the earth, and indeed the whole of space, could not be void. Space is thus, in Descartes' view, at plenum, being occupied by a medium which lay imperceptible to the senses. It is capable of transmitting force and extending efforts on material bodies immersed in it. The ether, as it is called. The word ether had its meaning in Greek originally as the blue sky or the upper rarefied atmosphere. Tesla talks about the ether in this fashion. Nature has stored up in the universe infinite energy. The eternal recipient and transmitter of this infinite energy is the ether. The recognition of the existence of the ether and the functions it performed is one of the most important results of modern scientific research. It has been for the enlightened student of physics what the understanding of the mechanism of the steam engine is for the barbarian. Newton stated that one body may act on another at a distance through a vacuum without a medium of anything is to me so great of an absurdity that I believe no man who has in philosophical matters a competent faculty for thinking can ever fall into. Thusly, under the advice of Newton and Tesla, why should the electrical engineer fall under the sway of Einstein and the quantum mystics? Okay, now if we want to get into the ether, that's going to be our first project here. Let's get into some basic physical relationships that work in that kind of way. Okay, basically, we'll deal with what are called the 5 states of matter. Okay, we have the first state, or which I would call the last state, or the bottom state of matter, is solid, or the elemental earth. The second state of matter is a liquid, or the elemental of water. The third state of matter is a gas, or the elemental of air. The fourth state of matter is plasma, or the elemental of fire. The fifth state of matter is the ether, or you might say the pre-elemental of prana. The kinetic theory of gases can give one an idea of ether concepts through pressure, temperature, volume, and mean free path. Faraday wrote on action at a distance again, matter cannot act where it is not, and I conceived the idea of magnetic lines of force or curves whose direction at every point coincide with the direction of the magnetic intensity at that point. Faraday considered that corpuscles of the ether, you might say atoms of the ether, or ether atoms, considered these to be arranged into tubes of force, and the strength of the field is then indicated by the separation or connection of these unit tubes of force. In other words, Faraday conceived of space filled with these fibers of etheric material. These tubes are contractive or tend to shorten themselves. In other words, they're like rubber dams. But they exert a pressure transverse to their length and are mutually repellent, like they're filled with a pressurized medium. Faraday writes, I cannot refrain from expressing my conviction of the truthfulness of this representation. Faraday's ether consists then of interlocking particles or corpuscles of the ether, which upon being made magnetic arrange themselves end to end, forming a line or slender tube. Maxwell says, thus if we screw iron filings on paper near a magnet, each filing will be magnetized by induction, and the consecutive filings will unite by their opposite poles so as to form fibers. Maxwell continues, the beautiful illustration of the presence of magnetic force affirmed by this experiment naturally tends to make us think of lines of force as something real, and is indicating something more than the mere resultant of two forces whose seat of action at a distance, and which did not exist there at all until the magnet is placed in that part of the field. We cannot help thinking that in every place we find these lines of force, some physical state or action must exist in sufficient energy to produce the actual phenomenon. Maxwell considered first the illustration of Faraday's lines of force, which is affected by the lines of flow of a liquid, and developed a hydrodynamic model of the ether upon which to base his development of electrical theory. That's why we have the term, some people still use the word juice for electricity. Maxwell again states, the facts, the consideration of which has induced me to regard magnetism as a phenomena of rotation and electric current as a phenomena of translation, speaking of motions in the ether. Maxwell says further, I suppose that the magnetic medium is divided into small portions or cells. So Maxwell came up with his first solid picture of the ether. I think that's the next chart. Oh, let's see.
Let's pause a second so I can change tape
Okay.
while you're getting up the chart.
Are we on the second
We're into the ether diagrams now.
So we're into the second
Yeah,
part.
yeah.
Okay.
Okay, we're recording.
It was really difficult to put all this together. There we go. So I think Maxwell's comes. So these are our basic lines of force that we're talking about. They don't show up too clearly on the screen. There we go. So if we have an electrified wire, the wire is not carrying electricity, but it's this induction in the space surrounding the wire that represents the electricity. The radial lines are what are called the electrostatic, or as Faraday called them, the dielectric lines of force. The circumferential lines are the magnetic lines of force. And at every point in space, they exist at right angles to each other. So one is basically the antitheses or the denial of the other. This will be the repeating theme that we will see through this whole lecture, is the conjugate relationship between magnetism and dielectricity. Now at every point at which these lines cross, where the radial lines cross the circumferential lines, this represents electromagnetic energy, and it is flowing into or out of the paper parallel to the axis of the wire. At that particular crossing point, we call that the unit of the Planck. And in Einstein or quantum ideas, it's called a photon. We go to the next one. Okay, now when we have a system of conductors which bounds the electric field, then it becomes trapped by the wires. That's why there's always more than one wire used in transmission systems, is to bound the ether between the wires. So now we have the radial lines of force are tending to pull the wires towards each other mechanically by shortening. The magnetic lines of force, the circumferential lines of force, are tending to fill the space between the wires and push them apart mechanically. At a certain stress point of the dielectric, which we would call the voltage, and a certain stress point of the magnetic, which we would call the amperage, the two forces counterbalance each other, and no force appears on the wire whatsoever, and this is called the natural impedance of the system, where the two energies are balanced out. We're going to get much deeper into this electric field. So if we're looking down the power lines, then this is the two wires, and we'll get deeper into this later as we go down. Let's go to the next one. Okay, so here's iron filings around the magnet, and you can see them lining up with the lines of force. In fact, actually, I have magnets passed around. Does somebody have those? The idea is, are they passed around? I thought I heard somebody click on them. Is that you, Bob? You got the magnets? Well, if we don't have them, I wanted you to actually feel this, but we didn't have time to put together his model. Okay, let me go on here now. Okay, so we haven't got the Maxwell cells. Let's keep going. Keep going. We can always go back. These are various lines. Here we go. This is Maxwell's paper on the ether and lines of force. Let's keep going. Okay, now this is a drawing out of this notebook. So this is what Maxwell thinks that the ether structures into in its electrified form, is this cellular construction. And then afterwards, we can read it. He gives this description. Go after it, then we'll read what he says. I suppose that the magnetic medium is divided into small portions of cells. The division or cell walls being composed a single stratum of spherical particles, these particles being electricity. The substance of the cells I suppose to be highly elastic, both with respect to compression and distortion, and I suppose the connection between the cells and the particles in the cell walls to be such there is a perfect rolling without slipping between them, and that they act upon each other tangentially. I then find that if the cells are set in rotation, the medium exerts a stress equivalent to a hydrostatic pressure combined with a longitudinal tension along the line's axis of rotation. If there be two similar systems, the first system, a system of magnets, electric currents, and bodies capable of magnetic induction, and the second composed of cells and cell walls, the density of the cells everywhere proportional to the capacity for magnetic induction at the corresponding point of the other, and the magnitude and direction of the cells proportional to magnetic force. Then we go to the page. So he makes his propositions here. We won't go through all this because it's a little more complicated. So let's go back to. Let me do some more reading here. Go back to the first flux diagrams. Okay, further back.
Don't be afraid to use your laser pointer.
Okay. Yeah, let me, that might be helpful. Okay, so here we have the crossing points. Okay, that's the electromagnetism. Then we have the circumferential lines of force, which is the magnetism, which is rotary in character, and is basically dimensionally considered velocity. Now we have the dielectric lines of force, which are everywhere at right angles by definition, being the antitheses of the magnetic. So basically, one becomes the gradient lines for the other. One defines the other in a conjugate or mirror sense. Now these lines of force move along in this direction. Now the magnetic lines of force must surround in closed loops the electrical or electrified objects. They can never end in space. In other words, this is just because it's gone off the paper. The dielectric lines of force must always terminate into what we will call counter space, or what J.J. Thomson called intermolecular dimensions. So by more conventional theory, we could say that this line of force is stuck to an electron on this wire, and this line of force is stuck to a proton in that wire. That would be your more physiochemical representation, but no one really knows what's going on inside these wires. And the electricity all moves this way down the paper at the speed of light. The ratio of these two quantities must always equal the speed of light. This was Maxwell's fantastic discovery that not only is the speed of light a velocity, but it is also the constant ratio between the amount of electrostatic or dielectric and magnetic energies in the system. And the impedance of this type of configuration always tends to be, again, a numerical value based on the geometry. But the speed of light has this duality, and this is where the confusions of Einstein and relativity and everybody emerged from, was this duality of the electric field as discovered by Maxwell. So I'm going to read some more Maxwell. We've gone through the cells. Okay, J.J. Thomson, as well as Heaviside, altered the Faraday-Maxwell concept such that now an electrostatic field constituted the tubes of force, and that a magnetic field was a secondary effect, or what Faraday referred to as the dielectric field. J.J. Thomson used the term Faraday tube to describe a unit line of electric force. Let's go to J.J. Thomson's diagram. Okay, here, go back. He's showing the attractive force exerted by dielectric lines of force between two bodies. Now, Thomson felt, unlike Faraday felt that the lines were magnetic, but Heaviside and Thomson felt that the dielectric were the primary and the magnetism was just that circling around the dielectric. You know, it's kind of like a chicken or egg consideration, and it's never really been fully resolved because the ether has no tangible physical dimensions. Okay, now what's happening is these lines of force tend to be contracted, pull the plus and minus together. And this basically is a representation of the process of attraction. Now we go to the next one, we have the process of repulsion. So in the process of repulsion, we don't have lines of force pushing the two objects apart. What it is the lines of force now have to terminate on more remote surfaces of molecular dimensions. And what it does is it pulls them away rather than pushes them away. So the repulsive process is not really a pushing apart, it's a pulling apart. And there's a void here in the middle of the absence of electrification rather than a concentration of it. Okay, now Euler's ether, and one which was described to by Tesla to compensate for, or to give an idea of gravity, that's further down the line here. We'll just cover that one briefly because it's specialized. Okay, now both Euler and Tesla felt that there was a type of gas where the mean free path of the particles was so intense because of their extremely high velocity that they would never hit each other in any fathomable distance through space. In other words, they could go for light years through space without hitting each other. It's a peculiar type of gas. Tesla confirmed the existence of these particles, which he called his cosmic rays, which are not really connected to the cosmic rays as they're told today. He had discovered a primary type of cosmic ray, which he said moved at 50 times the velocity of light. Now, what these guys all thought is that what gravity is, because it's not just simply two things attracting, something has to make them pull together. And we saw by the lines of force that what appears to be pushing apart is really pulling apart. If we look at it this way, is that these randomly moving ultra-gas particles strike an object, many of them will go right through. But these rays can be detected in the deepest mines of the world without suffering any attenuation. They can go right through the planet. But a certain amount of them will hit something. Now what happens is that creates a dead zone. So now you no longer have a uniform pressure of impacts around the object because the mean free path is so extreme that what it does is now this a void zone. You have more lines pushing here and more lines pushing here than you do here and here. And this is what causes objects in space to move towards each other, is they're actually pushed externally. It really is the most sensible view of how gravity operates. But it leads to some conclusions that are very unpopular. Because by this type of theory, all the planets and the sun have to be hollow. And people don't like to talk about that.